In this video, we're going to discuss variables and expressions. We're going to have a lot of new words and some definitions, so you may want to jot some things down as we go along. To begin, what is a variable? Well, a variable is going to be a symbol. It's usually a letter, and it represents a number that we don't know. So in algebra, the symbol that we usually go to first is the letter x. Another word that we need is going to be constant. And a constant is a number whose value is known and does not change, like 4 or -17. So let's kind of look at those two words together. We have a variable, we don't know the value. The constant, we do know the value. Variable, it could kind of be anything, and it kind of could change too, where a constant is it's not going to change. Okay, so let's take a look at some examples. If we have something like 5xy, can we classify each part to see what is a constant and what is a variable? Well, if a constant is a number and we know it, well, that must be the 5 right there because that's a number that we know. So I'm going to put a C for constant. And the variables are going to be symbols or letters, and they're going to represent numbers that we don't know. Well, I see an x and a y. Well, those definitely aren't numbers, so I'm going to assume that they are placeholders and they are variables, and they represent a number. So 5xy, 5 is the constant, and x and y are the variables. Well, let's look at another one. What if we have something like -7 plus x? In the last example, this was all being multiplied together, like one single big term. Here we have a couple of different things. We have a -7 plus x. In this case, the -7 is the constant, because it's a number, we know it, and x is the variable. We don't know what it is. Okay, so one more example. 5a minus 2b plus 4c. Okay, we've got lots of stuff going on here. We've got constants of 5, 2, and 4, because those are the numbers that we do know, and the variables a, b, and c, because those are symbols that represent numbers, but we don't know what they are right now. The next word that we're going to talk about is the word term. And term is a single number or a single variable, or it can be a combination of numbers and variables all multiplied together. In the example above, we saw 5xy, and that's a term because 5 is multiplied by x and multiplied also by y. And kind of all those things get crammed together and they're multiplied together, so we call that a term. So the next example we had was -7 and x. Well, this is not one single term because these things are not being multiplied together. They're actually being added. So -7 is a single term, and x is a single term. So really in this expression here we have two terms. -7 is one, x is the other, and these two terms are being added together. And we'll talk more about those later. Okay, so how about this one over here? Well, we've got 5a as a term because 5 is being multiplied by a. But then we've got a subtraction sign, so no more multiplication, so 5a is one term. And then 2b is another term, because 2 and b are being multiplied together. And then 4 and c makes one term, because 4 and c are being multiplied together. Anytime you have a number and a variable right next to each other, we're going to assume that they're being multiplied. So 5 times a minus 2 times b plus 4 times c. So now this one has how many terms? Well, 1 term, 2 terms, 3 terms. It has 3 total terms. So in each case, you can see a number being multiplied by the variable. So terms are just single numbers, single variables, or like a combination of numbers and variables that are all multiplied together. Another word that I want to talk about is the word coefficient. And a coefficient is just the number in front of a term. It tells how many you have. So in this third example up here, we had 5a minus 2b plus 4c. The coefficients happen to be the constants, 5, 2, and 4, because it has to do with how many we have. So in this case, how many A's do we have? Well, we have 5 A's. How many B's do we have? We have 2 B's. And how many C's do we have? We have 4 C's. So the coefficient is just the number that's out front of our term. It comes first, and it tells how many we have. Like if I say 3 apples, well, that means I have 3 apples. 3 is the coefficient, and apples is the variables or term or whatever you want to call it. Next, I would like to talk about the word expression. Now, an expression, you'll see in math, is just a mathematical statement with either a single term or it has multiple terms that are being added or subtracted together. So, all 3 of our examples above are going to be considered expressions, because in this case, 5xy is going to be a single term. So by definition, a single term is an expression. Or it could be multiple terms that are being added or subtracted. So in the second one, we had 2 terms. -7 was a term, and x was a term. And these rascals are being added together, so we say that this is an expression, -7 plus x. Our final one is another expression. We said it has 3 terms, and 5a minus 2b plus 4c is going to be an expression because it has multiple terms added or subtracted. We subtracted the first one, we added the next one, and so on. One quick point I would like to make about expressions is that expressions are not equations. And I know that students a lot of times get those two things messed up because they don't really understand what each one is. Now, in these examples of these expressions, there were no equal signs. We were not making some mathematical statement about something is equal to something else, or, hey, go and solve for this variable. An expression is just a standalone mathematical statement. 5a minus 2b plus 4c. There you go. An equation, however, is going to have an equal sign in it, and it's going to say that 2 sides of an equation are equal to one another. So notice that that is not what we have, and an expression and an equation are different. An expression is just a statement, and an equation is saying that 2 parts are equal to each other. Or you could say 2 expressions set equal to each other is an equation. One more word I would like to talk about before we start looking at some examples is the word product. And you may recall this word from grade school. The word product is the answer to a multiplication problem. So when you multiply 3 and 4, the product is 12. You may also recall that the 2 numbers that are being multiplied together to form that product are called factors. So in the previous case, 3 times 4 makes 12. 3 and 4 are the factors, because that's what's being multiplied, and 12 is the product. So if we have an example such as 6xy squared, this is an expression like we've talked about, and it's one term, and its coefficient is 6, and the variables are x and y, and in fact this y is being squared, so we know there's 2 y's. So we want to know, well, what are the factors of this? This is a big product. This is one number, one term here. What are the factors, and how can we know that kind of thing? So 6 can be broken down, because I know 6 is 2 times 3, and 2 and 3 are the smallest numbers that we can multiply to make 6, because 2 can't be broken down anymore, and 3 can't be broken down anymore. They are each prime, actually. So x here and y squared, well, x is just x. It's unknown. We don't know. And y squared is actually y times y. So we'll have y twice because it's being squared. So right here is what we call the factorization. So what are the factors of 6xy squared? Well, the factors are 2, 3, x, y, and y. Because when you multiply all these together, this is kind of the simplified form of that. Okay, let's look at some examples. So we're going to start here with, we'll start pretty simple. We'll start with 4x. Well, let's use all the words that we've learned so far and talk about 4x. Well, 4x is a single term. The 4 is being multiplied by the x. So the factors are 4 and x. Because when you multiply that, the product is 4x, which is our single term. 4 is a constant, and in this case it's also the coefficient, and x is our variable. Okay? So another one, let's say y plus 9. This is no longer a single term because we have an addition sign in here. We have y plus 9. Our variable is y. Our constant is 9. So let's see, on this y, what's the coefficient? Like, what's the number out front? Well, whenever you don't have a number written explicitly, it's always just kind of understood that it's a 1. So in this case, it's 1y plus 9. And this has two terms, we said. This is the first term, and this is the second term. And these terms are being added together. Okay, let's look at another example. What if we have something like -8? Well, there are no variables in this instance. It's just a number. And in fact, it's just a constant. So -8 we're going to call a constant. It's also a term. It's one term because we said the definition of a term was a single number or a single variable or like a product of numbers and variables. So this is a single number, so this is a single term. Okay, now what if we get a little more hairy? What if we say something like x minus 11 AMB? Okay, well, what all are the variables? It looks like we've got x and an A and an M and a B for variables, because those are the symbols that we don't know what they stand for. The 11 is the only number we have. That's going to be a constant. And also this 11 is the coefficient of AMB. And how many terms do we have? Well, it looks like x is our first term, and it looks like 11 AMB is our second term. It looks like we have two terms here. And we're having x minus 11 AMB. So the coefficient of A and B was 11, and recall the coefficient then of x, since there's not explicitly a number out front, is just 1, so we understand there to be just 1x. Okay, so let's get a really ugly one in here. Let's say something like negative 7p plus 2 over x minus 3. Okay, so uh-oh, there's throwing a fraction in there. That's not cool. Well, how many terms do we have? Well, negative 7p is going to be a term because this is being multiplied together. Negative 7 times p. And we have, what, 2 over x, which is kind of being multiplied together 2 times 1 over x, if you wanted to look at it that way. So this is a second term. And our final term is just a number, 3. So it's a constant. So let's talk about all these things. Let's talk about the coefficients. The coefficient on this first term is negative 7, because it's how many p's we have. We have negative 7 of them. You can always look at negative numbers as, well, maybe I owe somebody 7 p's, so I have negative 7 p's because I'm in debt. The next coefficient is going to be 2. We have 2 1 over x's, because you can kind of separate that out. And the last one is not really a coefficient because there's no variables. It's not how many we have of something. It's just our constant, like we said before. I would like to take a second now and talk about some special names that we give to these expressions. So sometimes if an expression has only one term, like our 4x or our negative 8, we're going to call that a monomial. And a monomial is a single number, a single variable, or a combination of numbers and variables multiplied together. Interestingly, you'll notice that that's the exact definition for the word term. So term and monomial kind of go together. They're the same things. Well, what if we have two terms, like our y plus 9 or our x minus 11 AMB? We're going to call that a binomial. And binomial is an expression containing two terms. So likewise, because we had mono and now bi, so the next one is trinomial. And trinomial is an expression containing three terms. And that's really where it stops. We don't have any more specialized names for things with more than 3 terms. It's just monomial, binomial, and trinomial. And those are prefixes that you'll see other places in life, like a bicycle versus a tricycle. Well, how many wheels does a bicycle have? 2. How many terms does a binomial have? 2. How many wheels does a tricycle have? Well, 3. And how many terms does a trinomial have? 3. So these prefixes are kind of helping us to know how many terms each one of these expressions have. So we've talked about a lot of different terms here. We talked about a variable, and we talked about a constant and a term. We also talked about a binomial and monomial and trinomial, and an expression and a coefficient. So that ends our discussion of variables and expressions.